Okay, we're going to wrap up this chapter by talking about systems of linear inequalities. So just like a system of linear equations, a system of linear inequalities is basically two or more inequalities put together that we're going to be graphing all at once. And the solution to the system of inequalities is basically any ordered pair that is true for all inequalities in a system. Okay? So let's take a look at the first example, and we are going to check which which ordered pair is a solution to the system of linear inequalities. And remember, it needs to be true for all inequalities. And I just realized I was writing pretty fast, so all my words are kind of jumbled up here. Okay, so we're going to take the x and the y for each of these ordered pairs and plug it in. And remember, if one doesn't work, then it's already not a solution, just like we did with equations. I'm going to plug in -1 for y, -2 for x, and -1 is definitely greater than -6, so that checks. Then I want to go ahead and check the next one. Again, plugging in -1 for y, and then -2 for x. Since the original equation has a negative sign, I want to make sure I have the negative in front. And -1 is less than or equal to 2 minus 2. -1 is less than or equal to 0. That checks. So -2, -1 is a solution. Okay, let's check the 0, 4. So again, you want to check both equations, or sorry, both inequalities. So I'm going to plug in 4 for y. See, is that greater than 3 times 0? 4 is definitely greater than 0, so that is true. And then let's go ahead and check the next one. Is 4 less than or equal to -0 minus 2? In this case, 4 is definitely not less than -2, so 0, 4 is not a solution. Okay, so pretty straightforward, right? The same type of thing we've been looking at for checking this entire chapter. So go ahead and try 1 and 2 and tell me if they end up being a solution. All right, so hopefully you saw for number 1, when you plugged in 5 for y for that top inequality, it already doesn't work. So we can stop right there and say it's not a solution. But with 2, since the first inequality worked, we want to check the second one. They both checked out, so 1, 4 should be a solution. Okay? Now what does the solution look like when we graph it? Let's take a look at how we graph a system of linear inequalities. Remember, with one inequality, we had one shaded region. Now, when we graph a system, we're going to have overlapping shaded regions. So the graph of the system of linear inequalities is basically the graph of all the solutions. Of the system, and those solutions are in the overlapping shaded region. Okay, so what we're basically going to do is we're going to graph each inequality individually and then just look at where the shading overlaps. So let's take a look at the next example. Okay, so I'm going to go ahead and use two different colors. If it helps you to work things out with two different colors, it's perfectly fine. I'd also recommend, for example, two different types of shading, and I'll show you what I mean by that. Let me just put in my number lines there. Okay, so the first equation, I'm going to go ahead and use red for this. right here, and it's y is greater than or equal to -1. So remember how we did this before? Y equals -1 is a horizontal line at -1. It's greater than or equal to, making it a solid line. And then I want it to be greater than -1, so I can test a point that's not on that line, so I can test 0, 0. And then 0 is greater than or equal to -1 is true, so I'm going to shade above. So what I'm doing here is I'm picking one specific type of shading, so I'm using vertical lines to shade, and I'm going to use something different for the next line. So look at the next problem, number 2. So for number 2, the boundary line is y equals -x plus 2. So I'm going to start at +2 as my y, using open circles because I know this is going to be dashed since it's just less than. Then we go down 1 over 1, or up 1, left 1. And this light blue dashed line is that first boundary line. Then I'm going to go ahead and test a point, and since 0, 0 is also not on that light blue line, I'm going to test 0, 0 to the original problem, y is less than -x plus 2, and 0 is definitely less than 2, so that's true, so I want to shade below. So now I'm not going to use a vertical line, I'm going to use a different line. And this is what I mean by using a different type of shading. So you can clearly see where the lines are crossing. That means this region where everything is overlapping, that I'm highlighting in yellow, this is the solution area where all the solutions to that system lies. So the solution area. Okay? I'm going to show you another way you can also do your work with C, and I just realized that's the exact same inequality, so let me tell you the right problem here, and then I want to show you an alternative, so and you guys can figure out what you prefer in terms of the shading and how you're going to keep track of your work. Okay, so let's change that problem to x minus y is greater than 2, and x minus y is less than or equal to -3. I'm going to go ahead and write in my number line first, going by ones. And then let's take a look at how to graph this. So remember, you can use 2 different colors, you can use those 2 different types of lines. I'm going to show you another possibility here, but what you want to figure out how you're going to keep track of your shading. Okay, so let's take a look at the first line. I'll use red again for this first one. And remember, if it helps, just get rid of that greater than sign and make it an equal to for now when we're thinking about the boundary line. And oops, that should be a y, not a 2. And then get that y equals mx plus b. So take away the x, then negative y equals -x plus 2, dividing by -1 to everything. My boundary line is y equals x minus 2. Then I want to make sure I'm seeing, okay, it's greater than, so it's got to be open circles, dashed lines. I'm going to start at -2, and I'm going to go up 1 over 1, up 1 over 1, or I can go down 1, left 1. And this dashed line is the boundary line for that first inequality. Then I want to pick my test point, so I'm going to test 0, 0, since the red line doesn't go through it. Going back to the original problem, x minus y is greater than 2. 0 minus 0 is greater than 2. 0 is not greater than 2. So what I want to do is I want to go down below. And what I've seen from other students in the past, instead of shading and having, all these scribbles everywhere, they like to use little arrows to represent which way they would actually shade. And then all the arrows should point at the combined region if they intersect. Okay, let's take a look at the second one. I'm going to do this down here. Again, I'm going to make this an equal sign for now, just so I don't have to worry about flipping the signs and whatever, and I can just deal with solving for y. Dividing everything by -1, I'm going to get y equals x plus 3. This time it's less than or equal to, so I'm using a closed circle at +3. Going to go up 1 over 1, or down 1, left 1. And this solid line is that boundary line for number 2. Then I'm going to go ahead and test 0, 0 again, because I can, into the original problem. So 0 minus 0 is less than or equal to -3. 0 is definitely not smaller than 3, so this is false. Just like that one earlier was false, right? This is false too. So I'm going to go ahead and shade above that line, so going away from 0. And what you're going to see here is that notice how the arrows are pointing away from each other. Nothing's actually going to intersect. So this is an example of no solution. So it is perfectly okay to have something that doesn't intersect. That just means we have no solution. Okay? Um, so go ahead and try 3, 4, and 5. Graph your system and let's see, does it end up with no solution? Does it end up with a solution? And if it has a solution area, make sure you label it. Make sure you show me where that would be. Okay? All right, go ahead and check. So again, it's up to you how you want to do the shading. So if you look for number 3, I did the lines, and then 4 and 5, what I did was I used those arrows, and I just followed, the direction of the arrows to create that solution area. But what needs to be very clear is where your solution is, or if there's no solution. Okay? We're going to finish this off in class. Please come back with questions, especially if you're still having trouble with graphing, because that's definitely something we want to make sure we review. Thanks for listening.